So in this second talk, I would like to talk about a problem that I call cross-translation unit test case reduction in C and C++. Please note that this is a problem statement and not a solution. So we are all familiar with the situation when we have this huge source code file that triggers a compiler bug or a compiler crash, and we want to generate a minimal example that reproduces the problem. And there's a methodology for this called Delta debugging, which is basically removing stuff from the file, seeing if it still produces that bug or crash, and repeating this until we arrive at a minimal example. Now, if you agree with me, I think the state of the art for C and C++ in this Delta debugging is C reduce. And the most interesting part of it is the set of compiler-like transformations called Clang Delta. And it's very cool. If there is one disadvantage to it, is that it works on one translation unit at a time. Why does this concern me? Well, my colleague Gábor Horváth presented to you 2 years ago a new feature in the Clang Static Analyzer called cross-translation unit analysis. This is kind of like an experimental feature still, so we are working on it. And my colleagues need minimal test cases for crashes and bugs that come up when we analyze multiple files at once. So just to illustrate, let's just see what happens during cross-translation unit analysis is we have this set of dependent files that contain the functions and classes that we want to use in our analyzed file, or we are using it, and we take their ASTs and merge them into the analyzed file's AST, creating this huge monster AST. And now the problem is, there was this one crash when cross-view analyzing Clang itself, when we had 72 preprocessed files, each 1,000 lines of code, and we only knew that the analysis was crashing, and like, good luck finding the bug, right? So it would be great if test case reduction could work across translation unit boundaries. And I can illustrate this with a much simpler example, simple, just multi-file compilation. So let's suppose that we have a.cpp that contains a function definition that has some bug in it, and b.cpp which contains a declaration and the use of that function. And now let's try to run this transformation of Clang Delta called parameter to global, which essentially removes the integer parameter of f and transforms it into a void. Now, if we try to compile it at this state, naturally we'll get a linker error because the signature of f changed in one file and didn't on the other. So you might just say, we just need to do the same transformation on the other file. But what is the same transformation? So in fact, Clang Delta at this point works with a counter of available transformation instances, which holds no information about the exact language elements that it transforms. So for example, if I ask Clang Delta to give me the available transformation opportunities for a.cpp, it gives me 1, because when it counts, it looks for function definitions. And for the other file, it gives me nothing because there's no definition of f there. Now the good news is that this transformation would handle all uses of f, including declarations and call sites, if they were in one translation unit. But they are not. So maybe we could find a way to connect these same language elements across the files, probably or maybe using unified symbol resolution. Well, we'll see. So this is a work in progress. Thank you for your attention. If you have any thoughts on this or you know a solution that works, please get in touch. Thank you.